Hello, 8th grade math students. Today we're going to be in Big Ideas Math, chapter 7.3, and we're going to be learning how to use the Pythagorean Theorem. So far, you've reviewed some vocabulary, you've read section 7.3 already, and you've labeled a picture of right triangles, and you've practiced squared roots. So you should be ready to further explore the Pythagorean theorem. If not, go back and do those other learning opportunities. You can either pause the screen and read this information yourself, or you can listen to me read it. The Pythagorean theorem is always interesting to me because Pythagoras was an interesting man, okay? And his club is kind of intriguing to me. So the Pythagorean theorem was one of the earliest theorems known to ancient civilizations. This famous theorem is named for the Greek mathematician and philosopher Pythagoras. Pretty cool name, right? Pythagoras founded the Pythagorean school of mathematics in Cortona, a Greek seaport in southern Italy. Okay, I would not mind living there, except for the coronavirus is there, so maybe. But after this is all over, yeah, I'll live there. Just kidding. Okay, he is credited with many contributions to mathematics, although some of them may have actually been the work of his students. Ooh, taking credit for your students' work. I don't know any other teachers who do that. Just kidding. I do it all the time. You guys are way more awesome than me. Okay, the Pythagorean theorem is Pythagoras' most famous mathematical contribution. According to legend, Pythagoras was so happy when he discovered the theorem that he offered a sacrifice of oxen. The later discovery that the square root of 2 is irrational and therefore cannot be expressed as a ratio of two integers greatly troubled Pythagoras and his followers. They could not sleep at night. They were having nightmares. No, I'm just kidding. But I'm sure they thought about it a lot. They were devout in their beliefs that any two lengths were integral multiples of some unit length. Many attempts were made to suppress the knowledge that the square root of 2 is irrational. It is even said that the man who divulged the secret was drowned at sea. Sound familiar? The Pythagorean theorem is a statement about triangles containing a right angle. Okay, right angle, 90 degrees. So the Pythagorean theorem states that the area of the square built upon the hypotenuse is the side opposite of the right angle. Hypotenuse, spelled kind of weird. Oh, I spelled it wrong. No E right there. Hypotenuse. Let's fix that. Okay. Of a right triangle is equal to the sum of the areas of the squares upon the remaining side. So if I take this side and I call it A, and see, here's my triangle in here. Whoops. And this is one of the legs, and I'm going to call it A, and I call this leg B. If I were to build a square on leg A, so here's a square. The area of this square plus the area of this square built on leg B equals the area of the square built upon the hypotenuse. Now, what is the area of a square? It's just the side, one of the sides times itself, right? It would be the area of this square. If this is A, it's just going to be A squared. And this would be B squared, and this would be C squared. So the sum of the areas of the squares are equal to the area of the square on the remaining side. So we get the Pythagorean theorem, which is a formula that states that A squared plus B squared equals C squared. Remember, this only applies to right triangles. It has to be a right triangle or the Pythagorean theorem does not work. Okay, while this theorem has been demonstrated mathematically on different occasions, not only stayed there, the Pythagorean theorem has many applications in real life. In architecture and construction, for example, is the most obvious application of this theorem because When you are working with roofs in triangular shapes, this theorem is applied when working with right triangles or triangles with an angle of 90 degrees. So you can find the length of the ladder here because this is a right angle. And if this were a right angle, we could actually make a right triangle here. From here to here, if we can find this length and this length, we can find the length of this side of the roof. That's probably how they use it more often in construction, and so on and so forth. So now that we know the secrets of the Pythagorean club, we can use their secrets to find the length of this hypotenuse of the triangle. Now remember, the hypotenuse is the side opposite the right angle. So here's the right angle. The sides adjacent to the right angle, you can call them either A or B. It doesn't matter which one's which. I'm going to call this one A, this one B. This is our hypotenuse. Now I can spell it correctly. And we know that A squared plus B squared equals C squared because Pythagoras or one of his students figured that out. So if A is 3, if we want to find the area of the square that would rest upon A, we would have to do 3 squared plus, if B is 4, that square would be 4 squared equals C squared. Okay, we're trying to find out the length of C, and so we don't know what the area of the square would be there yet. So in order to solve this, square means you're multiplying the number by itself. So 3 times 3 plus 4 times 4 equals C squared. 3 times 3 is 9. 4 times 4 is 16. That equals C squared. So 25 equals C squared. Well, I know what C squared is now, but I do not know what C is. In order to find C, so C squared is C times C, and the inverse operation for a square would be a square root, taking the root of the square. So I'm finding that root number that we've squared. So basically, it's the square root of C times C. Well, if I were to ask what's the square root of 16, 16 is actually 4 times 4, right? So that root number that we would find would be 4. So that would equal 4. So same thing here. C times C, C squared is just C times C. So that root number is C. So when I take the square root of C squared, I also, since this has an equal sign and it's an equation, have to take the square root of the other side. I cannot just take the square root of one side of an equation and expect it to stay equal if I don't do the same thing to the other side of the equation. So the square root of C squared is just C. So if you want to think about it, the square root and the square sort of cancel each other out. You can kind of think of it that way. Boom, 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 boom. And it just leaves a C there. And then the square root of 25 is 5. So your answer for the hypotenuse is 5, and since we're working with inches, it would be 5 inches. Okay, now we're going to find the length of the hypotenuse of this triangle. Okay, do you know what the hypotenuse is? It's from here to here. It is this length. Why? Because that's the length opposite the right triangle. Okay, and then these are our legs. This is our legs because these are adjacent to the right triangle, and we're going to call this one, let's call it B this time, and this one A. It doesn't really matter. You're going to get the same answer no matter what. So our Pythagorean theorem states that A squared plus B squared equals C squared. So our A is 15 feet. We don't have to write feet in the problem because those get confusing. The units get confusing. They look like variables. So we'll just put feet at the end. Okay, so 15 squared, because I want to square A, plus 8 squared equals c squared. Okay, 15 times 15. You can use your calculator. The little caret button means squared, and then you can put a 2, and that will square it for you. But I don't have a calculator with me right now, so I actually have to do the math, which is fine. I'm just going to pretend like I'm in Pythagoras' little club, and I like doing long problems. Okay, 225 plus 8 times 8 is 64 equals c squared. Okay, so now we're going to add these together, and we get 289 equals c squared. Okay, the problem is I don't want c squared. I want to know c. I don't want to know the area of the square that sits, on this leg, on this hypotenuse. I want to know what is this length right here. So how do I get rid of that squared? I do the inverse operation, which is the square root. And whenever you see a square and a square root, you know that those are going to cancel each other out. So you're left with c. Now, I cannot do a square root on one side of an equal sign without doing it on the other side. That wouldn't be how you would solve an equation ever. You have to do the same thing whenever there's an equal side that you do to one side to the other. So we've got to find the square root of 289. Now, if you have a calculator and you press the yellow button, it's usually light blue on the ones in class, but whatever color yours is, it will say second, and there's another button, probably another little symbol above another button that looks like a square root. You can press that to find the square root at home. So practice on that if you have a calculator at home. Otherwise, you've got to figure out, okay, what times itself equals 289? And hopefully it's a whole number. So I know that 15 times 15 is 225. So it's got to be bigger than 15. Is it going to be 16 times 16? No, I don't think so. But maybe. No, 256. So let's try 17 times 17. That's 49. Plus 11. Okay, and then that's, I gotta move it over here. 1 times, do my placeholder. 1 times 7 is 7. 1 times 1 is 1. That's 289. So the square root of the square root of 289 is 17, and our hypotenuse is 17 feet. So have fun with these. Remember, you need this formula. Write it down. Don't just watch the video and try and remember it. Find where the right angle is. Label the legs. And then make sure that once you square everything and you're left with c squared, you take the square root of each side to find your hypotenuse. All right, everybody, happy learning. There is a short Google form that you can answer some questions on that go along with this. And have a great day. See you later. Miss ya. Bye-bye.